Good evening, everyone. Welcome to another night of math with Mrs. Taylor's math class. Good evening, good evening. So, tonight I want to focus on GED math questions again, just to give you a sample of what could possibly, the topics you could possibly see when you take the GED. So, without further ado, let's go ahead and get started. If you know anyone who is interested in taking the GED and need some help, they can contact me at on Mrs. Taylor's math class, and all of my contact information is on my page. So tonight we're going to do some more questions like we did last Monday. So let's get started. So the first question says, which of the following shows the correct unit for the circumference of a circle? So when you talk about a circumference of a circle, first off, the formula is C is equal to pi um, D, or you can use the formula C equals 2 pi R. But what you're interested in is this particular variable here or this one. And because the exponent here is a 1, when you get your answer, it's also going to have an exponent of 1. So it's going to be just shows the correct units. The square units is usually for area. The cube units is for volume. Anything more than that is this is just like for a polynomial. Okay, let's go to the next question. Given the diameter, what is the formula of the area of a circle? So first off, the area of a circle is area is equal to pi r squared. But if you notice, all of your answers are in terms of d, which is for the diameter. So what we would need to do is focus on the relationship between the diameter and the radius. So what we know is that the radius is equal to the diameter divided by 2. So what I'm going to do in place of the value of r in this particular formula, instead of putting r, I'm going to put d divided by 2. So if you have a is equal to pi, and instead of putting r squared, I'm going to put d divided by 2, and then I'm going to square that. And so if I keep going, I have my pi. D squared is the same thing as saying, and let's make sure we get this straight. D squared is not d squared times 2. It is d over 2 times d over 2, which is d squared over 4. So this is going to get you d squared over 4. And so none of the answers are written in this format, so you have to rewrite it as this one. So I can rewrite as a equals, and I can put 1/4, and it's times pi times d squared. And so you want this answer choice here. Okay, next question. A Senate Committee of Indigenous Affairs is to be formed from a group of 7 indigenous and 8 non-indigenous senators. If there are 5 members in the committee, and it must have at least 3 indigenous members, in how many ways can the committee be formed? So with this particular question, you got to use combination. I don't know if you ever heard of that, but we're going to have to use combination. And that's like C equals N and R, okay? So for this question here, it's like 3 different scenarios you have to consider. First off, you're trying to form a committee. So you're trying to form a committee. And your committee has to have a certain amount of people. First off, it has to have 5 people. 1, 2, 3, 4, 5 people. And the criteria is that it has at least three of the people have to be indigenous members. Okay, so the first three, we'll split this up, has to be three, and I'm gonna put ID for indigenous member, and then the other two could be non indigenous members. Okay, that's just one scenario, because when they say at least, that means I can have more than three. I can have three or more than three. So another scenario would be I have 5 seats on the committee, and I can have four of the people can be indigenous and one person who is non-indigenous. Okay? But then there's one more scenario. They said at least three. So that means that I could have all 5 seats could be indigenous people. Okay? Not indigenous people, indigenous members of the Senate. Okay, so we have to consider each one of the scenarios. So I'm going to say this is number one, number two, and number three. So you're trying to find out how many ways can the committee be formed. So we have to use the combination. So for this question here, let's consider the first scenario. So if we have, and I'm going to be erasing a lot, so let's see. We have one, two, three, four, five. And so the first combination is going to be C, and I have 7 indigenous people, but I got to pick 3 of the seats. And then I have the other combination is I have 8 non-indigenous people, but I got to pick 2 people to be in that seat. Now the formula for combination is going to be this. You have n factorial over r factorial times n minus r factorial. Okay, so to set up this question here, the first one is going to be, if it's going to be C7, 3, the combination of 7 and 3, it's going to be 7 factorial over 3 factorial over 7 minus 3 factorial. I remember doing these. I used to think that this was so hard, but these are actually easy. So this is what this means. Factorial means that you just start at 7 and then multiply down. So it's just 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what that means. And then 3 factorial is 3 times 2 times 1. And then, so this right here, this portion right here is equal to 4 factorial. So then I'm going to say 4 times 3 times 2 times 1. Now that's a lot to multiply, but here's how you get away with it. You see this 4 times 3 times 2 times 1? It matches this one down here. So we're going to cross that out. We ain't got to multiply that. Okay, and then if you look here at the bottom, the 3 times 2, this equals 6. So I could cross this out and this 6. So what I'm left with up top is just 35. I'm left with 7 times 5, which is 35. So 7, the combination of 7 and 3 gets me 35. So there's 35 ways to pick this combination here. Now let's do this combination of 8 and 2. So we have C, the combination of 8 and 2. So this is going to be 8 factorial over 2 factorial, and then 8 minus 2 factorial. So this is going to be 8 times 7 times 6, 5, 4, 3, 2, and 1. And then down here, 2 factorial is 2 times 1. And then this is 6 factorial. So this is going to be 6, 5, 4, 3, 2, 1. Okay, it looks like a lot to multiply, but we can simplify the factors. We can cross out this 6, 5, 4, 3, 2, 1, and this one as well. Okay, and so what we have left over is 8 times 7 up top, and then 2 times the one at the bottom. But I also can, well, let's just make it easy. We'll do it like this. We'll say 56 over 2, and that's going to get me 28. Okay? So for this combination here, for the combination of 8 and 2, you get 28. All right. Now, what's the combination for having 3 members who are indigenous and 2 members that are not indigenous? You have to multiply this together. So what is 35 times 28? And of course, I'm gonna pull out my calculator because that's what I do. 35 times 28, and I don't even know I don't know the rules of the GED, but hopefully you're able to use a calculator. So this right here, this combination is going to get me 980. So I'm going to put this down here. So this was 35 and this was 28. And when you multiply it, you get 980. Okay, so I got a lot more work to do. So I'm going to erase this portion here and then go to the next scenario. So let's erase this. Erase. And let's use a different color. That way you know I'm on to another situation. Okay, so let's use green this time. Okay, so I'm going to do the combination of, we have 5 members. 1, 2, 3, 4, 5. We're going to make 4 of them indigenous. So that's going to be the combination of 7 and 4. And then 1 that's not indigenous. And that's going to be the combination of 8 and 1. So let's do our math. So this combination of 7 and 4 means 7 factorial over 4 factorial and over 7 minus 4 factorial. So this is going to be 7, 6, 5, 4, 3, 2, 1. And then we have 4, 3, 2, 1. And then this is 3 factorial here. So that's going to be, hold on. Excuse me. So it's going to be a 1 and then 3, 2, 1. Okay, so I'm going to get rid of this 4, 3, 2, 1 and this one over here as well. I know that the 2 times 3 times 1 is getting me 6. So I'm going to cross out this 6. Again, I'm left with 35. That's a good thing. So I got 35 for up here. So I put that right here. It's 35. So now let's do the other one, the combination of 8 and 1. So we have 8 factorial, and this is going to be 1 factorial, and this is 8 minus 1 factorial. So this is 8, 7, 6, 5, 4, 3, 2, 1. And then this is this 1. And then this is going to be 7 factorial. So this is 7, 6, 5, 4, 3, 2, 1. Cross those out. And you just left with 8. So this one's going to get me 8 here. So we multiply these two numbers together. 35 times 8. Let's see what we get. We get 280. Okay. All right, let's keep going. Now, thank you, Ryan. I'm glad I'm able to make this very clear for you. Okay, so now let's go to the next one. Let's use a different color. And let me erase this here. Erase. Now, the last combination is all 5 members of the committee are indigenous. So, 1, 2, 3, 4, 5. So that's going to be the combination of 7 and picking 5 members. So it's going to be C, 7 and 5. It's going to be 7 factorial over 5 factorial and 7 minus 5 factorial. So you could do, this is another way to write this. I could actually say 7 times, times 6. And if I didn't want to write the rest, I could just do 5 factorial. And I'm going to show you what I'm going to do with that. And then this one, I could leave this as 5 factorial. And this would be 2 factorial. And I know that's going to be 2 times 1. Now, because I have a 5 factorial in my numerator and 1 in my denominator, I can cross them out. I don't have to write all that stuff out. And this is beneficial to know for when you're using higher numbers or larger numbers. So I just write what I need, and then let's keep calculating. So I also know that 2 times 1 is just 2. So if I cross out this 2, I can cross out this 6, and it's left with a 3. So now I'm just left with 7 times 3, which is 21. So this combination here is just 21. So now they want to know, in how many ways can the committee be formed? All you do is add up all 3 of your combinations. So I have 980 plus 280 plus 21, and the combination that I get, let me verify my calculations, is 1,281 ways to form the committee. And that's just answer choice here. Okay, let's go to another question. Those are fun. I love factorials. I think the first time I ever saw them, they were like, who in the heck puts the exclamation mark in math? But guess what? We need it, and it's easy. It's so easy. It's not hard at all. It looks intimidating, but it's not. Okay, let's go to another question. This question is a good question because some people don't even know how to calculate their grade in class. When your teacher uses percentages to calculate your semester grades or your class grade, some people are just like so confused. Even some teachers are confused how to do that. That's why they do straight points. So, but I'm gonna show you tonight what you need to do. Okay, so it says the final grade for an engineering class is comprised of quizzes, 20%, class participation, 10%, papers, 20%, exams, 40%, homework, 10%. If a student got the following grades in each component, quizzes 90, class participation 80, papers 70, exams 80, homework 100, what will her final grade? What would be her final grade? Okay, so for this one here, let's start at the beginning. So quizzes are 20%. And class participation is 10%. We got to write them all down so we can get this right. Papers are 20%. Exams are 40%. And homework is 10%. And that's all of them. So first off, all of this has to equal to 100, does it? So we got 20, 30, 40, 50, 60, 70, 80, 90, and 100. So we got 100%. That's how we get the 100%. All right. So for each one of them, they tell you what the person scored in each category. So for the quizzes, she scored a 90. So we take the 90 and multiply it by 0.2. Now for the class participation, she got an 80. Multiply that by 0.1. So you got to change all of your percents to a decimal. And basically all that is when you change your percent to a decimal, you're just moving the decimal place 2 places to the right, to the left. 1, 2. So 20% is 0.2 as a decimal. Okay? So that's all I'm doing here. So for the participation, you have 80 times 0.2. Exams. Wait, I skipped one. Hold on. Quizzes, check. participation check. Oh, papers are 70, not 80. Hold on. Okay, there we go. So papers are 70 times 0.2. All right, I got that. And then exams are 80 times 0.4. And then the homework 100 times 0.1. So let's calculate each one. And when we get a calculation for each one, we just add it together, and there's the grade. So you take 90 times 0.2, and she got 18 points out of 20. Now you take the 80 times 0.1, and she got 8 points there. And then she did 70 times 0.2, and now you have 14. And then for the exams, did I do that right? Hold on. 70 times 0.2. Yes, right. Okay. And now you do 80 times 0.4, and you get 32. And then 100 times 0.1, and you get 10. So all we need to do now is add all of our quantities together. So we have 18 plus 8, 18 plus 8 plus 14 plus 32 plus 10, and you got an 82% out of 100. So that's what she has in her engineering class, 82%. Okay, let's keep it moving. Um, Next question. So for this question here, it says the student is trying to calculate the score he needs in the final exam to pass a math class. There are only 2 exams in a semester, and they make up 40% of the student's total grade. He got an average of 75 in the remaining. He got an average of 75 in the remaining 60% of his grade, and he received a score of 50 in the midterms. What is the minimum score he needs in the final exam, and if the passing score for the class is 70? So let's break down what's going on in here. So first off, there are only 2 categories. There's one category for the exams, and then 60% for all the other activities that they have in the class. So the category for exams is 40. And then we'll just say O for other is 60%. Now they already said in the other category he has an average of 75. So we know we're going to multiply that by 75, okay? And then we'll get an answer for that. But let's go back up here to the exams. Now for the exams, there are only 2 exams, okay? He already got a 50% on one exam. He wants to know what's the score he needs on the final exam in order to get a 70%. All right, so let's set up this question so far. So for the exams, I know he has a 50 plus his final exam, and then of course you're going to get an average for that. So we're going to divide that by 2. Okay, and we get an answer there. Now he wants his score to be a 70%. So let's go back up so far. Let's go right here to the other. The other, if I say 0.6, so let me write it out. I'm going to say 0.6 times 75. And what's that? 75 times 0.6. Okay, so he has 45, right? He needs 70. He needs a 70. In order to get the 70, we got to figure out what does the exam category need to add up to. So if let's do 70 minus 45. So 70 minus 45 is 25. So he needs to get 25 points, and I'm going to do like this. He needs to get 25 points out of this exam category in order to make a 70% out of the whole class. So right now, I'm just going to do the math for this. I'm going to solve for F, which is going to be for the final exam. So let's do this math over here. Let's say the final exam or the exam category is going to be 0.4 times 50 plus the final over 2, and we're going to put that in parentheses, and it needs to equal 25. Okay, so the first thing I'm going to do is a couple of things I could do. Let's see what's the easiest that someone can understand. Because there's a different ways to manipulate all of this. Let's do it like this. Let's break this up. So let's do 0.4 times 50 over. No, I'm not going to do that. I'm just going to do it. And if you need some more help, I'll break it down to you again. Oh, goodness. I'm tripping, y'all. Let's do it like this. No, let me do it. Okay, 0.4. Let's do this. 50 divided by 2 is 25. And then this would be F over 1/2. So this is really going to be 0.5 F. Let's do it like that. That's what I'm going to do. And so now I can multiply, or I'm going to divide both sides by 0.4. Is that what I want to do? Yeah, let's divide both sides by 0.4. Let's do that. Okay, so this will cross out. So this would be 25 plus 0.5 F is equal to, let's see, 25 divided by 0.4. It's going to get me 62.5. So once I do that, I can subtract 25 from both sides of the equation. Minus 25, and I get 0.5 F is equal to 37.5. Now, now I can figure out, this is going to be the last step. Divide both sides by 0.5, and so my final exam has to equal, drum roll please, 75. So he needs to get a 75% on his final in order to get a 70% out of the not the engineering class, what class is this? The math class. Okay, let's keep it moving. What is the simplified form of 116 over 148? So this is just, I know back in the day we used to say reduce the fraction, but they like to say simplify now. So 116 over 148. So this one here, I would just, if you're not sure what number goes into both, you can always start with 2 because they both end with in an even number. So start with 2, start simple. So 116 divided by 2 gets you 58. 148 divided by 2 gets you 74. But see how both of them end in an even number again, an 8 and a 4? You see that? Divide by 2 again. Just keep doing it till you get down to the lowest terms. So 58 divided by 2 is 29. 74 divided by 2 is 37. So guess what? You can't do anything else with this, all right? So both of these numbers are what they consider to be prime numbers, meaning they only are divisible by 1 in itself. But that's a whole nother thing. But this is how you know you're done. So the answer here is going to be 29 over 37. Okay, so I think this is my last question. So here it says a fraction where the numerator is less than a denominator is called a what? This is what we call a proper fraction. Gotta know that vocabulary. But what is this other stuff? So let's define the other stuff. So a proper fraction is just like what we just did. 116 over 148. That's a proper fraction where the numerator, which is your top number, is less than your denominator, which is your bottom number. Okay? But what is a mixed number? A mixed number is a whole number plus a fraction. And I should say, you know what? Let me be very clear. Well, no, it's a fraction because it could be a proper or improper fraction. You just have to manipulate it to make it right. So a mixed number. So for instance, 2 3/7 is an example of a mixed number. What is an improper fraction? An improper fraction is where your denominator is going to be less than your numerator, or your numerator is going to be more than your denominator. So for instance, 81 over 7 is an example of an improper fraction. Okay, and like fraction is fractions that are alike. So that's it. So we are done for the evening. Thank you for watching and commenting and sharing this video. If you know anyone who is interested or in the process of studying for their GED, send them my way. They can look at this video or any other videos that I have on YouTube pertaining to the GED. If they need additional help, I am available for tutoring. They can fill out my tutoring information form on the Mrs. Taylor's math class on Facebook. So until next time, ta-ta for now. Bye-bye.